Hello children, this is the third part of the chapter Exponents. In the first two videos we learned what exponents are and we learned 4 laws of exponents. Here we are going to learn about the fifth law of exponent. Now what is the fifth law? Fifth law states that when the powers are same with different base, then the power is taken as common. That is, if a raised to power m into b raised to the power m, then this is equal to a into b raised to power m or ab to the power m. Either we write it in this form or we write it in this form, both are same. Vice versa, if it is given a b raised to the power m, this means a raised to power m multiplied by b raised to power m. That is, when the power or exponent is same with different base, the power is taken common. Take an example, 5 into 4, that is AB. A is 5, B is 4. So 5 into 4 whole raised to the power 3 means 5 into 4 is multiplied 3 times. So 5 into 4 into 5 into 4 into 5 into 4. 5, 5, 5. 3 5s are there. 5 into 5 into 5. 4, 4, 4. 3 4s are there. So 4 into 4 into 4. This is equal to 5 raised to the power 3 into 4 raised to the power 3. That is a raised to the power m into b raised to the power m. Now coming to the sixth law, a raised to power 0. Any number raised to power 0 is equal to 1. Or if it is any rational number. What is a rational number? A rational number is in the form of a by b or p by q or c by d. Any number which has a numerator and a denominator, and the numerator and the denominator are integers and the denominator is not equal to 0 are rational numbers. Right? A by b, this is the numerator, this is the denominator, and the denominator is not equal to 0, then that form of a number is known as a rational number. Now a by b is a rational number raised to the power 0 is equal to 1. We'll find it out with the help of an example. See, 4 raised to the power 6 divided by 4 raised to the power 6. 4 raised to power 6 by 4 raised to the power 6 is both cancels is what? 1. So if we use the rule of exponent over here, that is 4 raised to power 6 divided by 4 raised to the power 6 is equal to 4 raised to power 6 minus 6. 6 minus 6 is 4 raised to the power 0. That is equal to 1. A raised to the power 0 is equal to 1. So any number raised to power 0 is equal to 1. The same rules apply for rational numbers. For any rational number a by b and c by d, a by b is one rational number, c by d is another rational number, and positive integers m and n. We have positive integers m and n. Now take this rational number a by b to be a and a to the power m and a to the power n is equal to a to the power m plus n. So a by b raised to power m into a by b raised to power n is equal to a by b raised to power m plus n. Similarly, what we learned in the second law was that a raised to power m divided by a raised to power m n If m is greater than n, then it is a raised to power m minus n. Now here we have taken rational numbers. So a by b to the power m divided by a by b to the power n is equal to a by b to the power m minus n. If m is greater than n and ab is not equal to 0. The third law for a rational number, a by b to the power m divided by a by b to the power n is equal to 1 by a by b to the power n minus m. When it is n minus m? When the power of the denominator is greater than the power of the numerator. That is the second case after the division sign, whatever is there. If that power is greater than the numerator's power. M is less than n and a by b is not equal to 0. The fourth law for the rational number, a by b raised to power m and whole raised to power n. If we remember, we had learned that any number which has a power is raised to another power, then the powers are multiplied. So it is a by b raised to the power m into n. The fifth law, a by b into c by d raised to power m equal to a by b raised to power m into c by d raised to power m. This is a, b raised to the same power is equal to a to the power m into b to the power m. A by b raised to power 0 is 1. Any number raised to power 0 is 1. Any negative number raised to the power 0 is also equal to 1. Hope all the laws regarding exponents is now clear, and in the next video we will be learning how to simplify sums on exponents, which will help you to solve the exercises of the chapter.